Okay, hello. Welcome to another walkthrough. Today I'm going to be going through a case from the 2024 Brazilian Championship semi-finals. This was called Letter Soup by Klinsmann and Dearmid. And it should be a relatively quick one. Levels 1 to 6, pretty straightforward. Level 7 involves kind of a programmatic solution. So we'll probably spend the most of the time on that, but hopefully this should be well under 30 minutes, maybe even 20. So without further ado, usual caveats. I've done the work case before. This isn't a live solve. This is me going through afterwards, identifying what would be a good solution. So let's get straight into it. So it's all to do with basically strings of letters and characters. So how many times does the displayed character appear in the text string? So I've got a lambda for this called count occurrences. We're told that in this first case, this is case sensitive. So I'm going to look for occurrences of this within this string, and I'm going to set the case sensitive optional argument there, because normally it's not case sensitive, because most of the time we generally don't need it to be. And then this time we're looking for how many times does the displayed character, and this time we're not case sensitive, so we can just basically do the same thing, but this time we don't need to put in that optional argument for case sensitivity. And the count occurrences, just underneath the hood, all that's doing is counting the length of the string, then counting the length if you removed all of the relevant characters, with a slight variation for case sensitivity. Right, level 3, right, we're going to go on to data tables just to make this easier to visualize. So we want to differentiate vowels and consonants considering the 26 letters where A, E, I, O and U are the vowels. For each text string, find the position where the requested type had all of its letters completed. So let's start by just identifying the vowels as A, E, I and U, and then my consonants are going to basically start off with a list of the alphabet, which we can see there. But what I want to do, I'm going to use my include exclude lambda, where I'm going to take this list, filter it by this list, but basically exclude anything from that list, so we then get a slightly shorter list of consonants. Now what I want to do is find out when each of these characters first appears. So searching all the vowels, when do they appear within this list, and we get the number, and we want to know when we've finished, so what is the maximum of these. So on the 33rd character we find the E, which is the final one, and we should be able to just copy this over, but it won't work because my reference isn't locked. So we get that, but in this case we also need to search the whole of this string, not just those first 5 characters, and we'll see that some of them return errors, which means they're not found at all. So what I'm going to do is going to put if error, then we'll just put 999 as a kind of max figure, and I should just do the same over here. So although there's no errors on this particular example, we may have errors on future ones. And then we're asked to find whether it's vowels or consonants. So I can now just use XLOOKUP, which is why I've put the names vowels and consonants in these cells. And it will find, it would if I had told it what to look for, B1 in that range, and we get all of our answers. Okay, let's move on to level 4. So this time we're given a string, find the first unique character in each text string presented. The term unique means that it appears only once, and the comparison must not be case sensitive. So A and A, lowercase and uppercase, are the same thing. So let's start by grabbing the alphabet, so we know all of the letters we're looking for, and then we're going to search for each of these characters, and search is not case sensitive, so we don't need to do anything with the original string. And we find all of the instances, some we don't get, so again we will put an if error, then basically means we didn't find it, so we'll just put 999 for the time being. And then we want to find when they are, if it is unique, so how many of them there are in total. So we're going to just use our count occurrences. So to start off with, so we're going to count the occurrences of these within B1, which is not case sensitive unless we tell it to be, and then we want to know the ones where that equals just 1, so times where there is only one of them. So we then convert that to ones and zeros, and we get this. So we now just want to find the ones where we actually found it, so I'm just going to say this times this. So we now have the letters where it was found, and we want to find the ones which is the smallest. So I'm going to filter, what do I want to filter? I want to filter this where this doesn't equal 0, and then I want to sort that in reverse order or descending order. I need to sort. My sort index is 1, my sort order is -1. Actually, I think I need it ascending. So the 5 is the first time we come across something. So then what I can do is I can just say @ just for neatness. And then what I want to say is I want to look into the original text string in that position, 1 character, and we get Z. And if we point our data table to that, it's a little bit slow, but it gets there eventually. So we've got our work cut out, work sorted there. So let's go on to level 5. So find the position for each text string where the first size n clipping of non-repeated characters begins. A bit complicated, but the example makes sense. So in example 5, the first cut of non-repeated characters starts at position 48. In other words, the first time we come across 16 letters in a row, which are all unique, happens when we get to the 48th character. So what we need to do is basically, and this is not case sensitive, so to make this easy, I'm going to just turn the string into uppercase. Oops. Uppercase C1. I want to know how long the string is, and therefore how many possible kind of substrings there are, which is going to be the length of the string minus the length of the string we're searching for. So in this case, 48. So I'm now going to make a sequence of 48 because I'm basically going to start at every single one of these possible positions and test whether or not it meets our criteria. So what we're going to do, we'll build this one step at a time. So we're going to say mid of our string, starting at this and going through this many characters. So for that first one, we would get that, and so on. So we get, it would help if I locked this. So let's turn F4 needs to be locked and B1 needs to be locked. Well, this won't actually matter because we're going to build this into a lambda that does it all together. And let's just put those to the left so we can see that those are changing each time. Then what we want to do is we want to text characters that, so split it out into its actual characters. Then we want to unique it. So we only have the unique. We then want to count how many there are. And we want to check whether that equals the size of the string we're leaving for. And that first one is false. And if I were to drop that down, we're getting all falses, but we should get one at the end. Is that because I didn't lock that second reference to B1? So if I did that all the way down, we get a true right at the end there, but I want this to be dynamic because the sequence is going to be different each time. So I'm going to call this lambda. We're checking a starting point, so we'll just call it start. And we'll replace the E10 with the start. And that gives us our lambda. I'll get rid of all of this. And then I can just say by row on this sequence using that lambda. We get all our falses and then one true. And so then our final answer will be to filter a sequence where the test is true. So in this case, we get 48. And we point to that. Oh, don't know what's going on there. Oh, slightly wrong there. Oh, something's gone very wrong. Let me just check, have I hard-coded something? Let's go back to, we're on example 5. Something very funny just happened. I'm not really sure what it was. Let's try that again. Let's, what is it giving me? So our sequence is based off possible length. I've got a lot of data tables working in the background, so I might just pause and undo the other data tables. Okay, I've closed a few other things, so hopefully this will work a bit better now. I think this first example is working. I don't know where this IMG log thing was appearing, if you saw that there, but anyway, good, that's working. Right, let's move on to level 6. In which position was the nth pair of uppercase, lowercase letters completed? So example saying the first pair is found is D and then D in 3 and 4, and then the second is U and then U. So we basically need to find where everything is, each pair is completed. So I'm going to start with the alphabet in the upper, and then I'm going to do my alphabet but with the optional lower argument. So we're then going to say, where can we find, and we're using find this time because find is case sensitive. So we want to find this within C1, and we're going to wrap it in an if error, then just return 999 to say we didn't find it. We'll copy that over. It won't work because it's not pointing at the correct cell. If we change this to C1, and then what we want to do is find, go through each pair and check the max of each row. So we can do this as a lambda using map. So we're going to map over this column and this column. I'm going to go lambda, call these A and B, and we just want to know the max of A and B. Close that all off. and we get the max. So we see that D is finished on 4 and U is finished on 6. And then we want to find, we're not always finding the minimum, we're finding in this case the second. So we can use small. Our array is these values, and this is our number, and that's all we're asked to return. So rather than returning the actual letter, and we get level 6 done. How are we doing on time? 10 minutes. Yes, so we need most of our time for level 7, which for some reason I don't have the question there. So let's just quickly grab that. And this was very difficult because it involves effectively, like I said, a programmatic solution, because what we're going to do, we're going to start by text characters on B1. And I've got something left over from previous work. And then what I need to do is I need to kind of work out the pairs of these. So what I'm going to do is I'm going to say unique. Let's hope that all 6 possible items are included in this example. They are. So let's just copy those as values only, and then let's just match up the pairs. Oh, copy and paste as values only. So our close square brackets goes there, close normal brackets, and then curly brackets. And I'm going to put these here, and I'm going to name these. These are our closes, openers. So these are when we open a set of brackets, and these are our closers. So when we close a set of brackets. And so first thing I want to do is work out what is the opposite of each one. So let's look up these values in our, actually, because we don't have, they won't always be matched. Let's also create a duplicate set underneath where they're the opposite way around. So I can then say look up these in this range and returning from this range. So that tells us what kind of the pair, how these are paired up. So what we're going to do, we're going to start by assuming the first one is always okay. That I think it wouldn't have made sense to have an example that failed on the first attempt. So we're just going to point this to the first character. So that is our set as it is at the moment. And then what we're going to do is we're going to try and add the next character each time and see whether it breaks the rules. So we just need to think about this quite carefully. So we're going to build this as a let. So I'm going to call whatever's happened before, let's call this the previous step. It refers to whatever's before, and the next character is whatever is coming next. Okay, so right now that's just returning. If I could join those together and say that's what we should have, and that doesn't break the rules, so that's fine. But we need to know why that is the case. So the first thing we need to know is that if it is an opener, then we can add it on. We can always open up a new set of brackets. The issue comes when we have a closer and whether it closes the previously opened set. So what we want to do is say, do we get a number if we X match the next number in the openers list? Okay, and if I just say is opener for this first one, it's going to be true because it is an opener. So we can basically open it and that's fine. We also want to check what was the last item in the current sequence. So I'm going to call this last item, and we'll just say right of the previous. So what is the last valid item? And then what we want to do is check whether the next item is kind of effectively the next item closes the currently open pair. So I'm going to call this close pair, and I'm going to check whether, and this is where I need to be very careful, whether the last item, so the last item, which is whatever is kind of on the furthest right of where we are up to now, whether that equals the opposite of the next item. So this whatever is in value in the kind of F5. So have we got a closed pair? In this case, we don't. But if we did, what we would have is the last item is, in this first instance, that. And if the next item is a closer for that, then we would return true. What we can do is if we close the pair, we can actually remove the pair. So let's see if we can put this all together in our final logic. So if is an opener, so if it's an opener, then all we're going to do is say previous and next. So we're just going to add it onto the current string. If it's not an opener, so if it's a closer, then we need to check, has it successfully closed a pair? So if it closes the pair, i.e. the thing directly in front of it is its opposite, then what we're going to do is we're basically going to say, we want to say the left of the previous. So So we want to grab what's there, but we basically don't want to add anything, and we actually want to remove the previous character. So we're going to say the length of the previous, whatever that might be, -1. So that's us removing the previous character, and we're not also adding anything here. So we just leave that as is. Otherwise, we need to do something else. Something else is going to happen, and basically we're going to have an error. When we close that, we've got a slight issue here. So I've got a bracket move-ish somewhere. Length previous -1, I think. Oh yes, I need to close that bracket there. And on this first one, that's fine. Next one's fine. You'll notice this next one, we actually closed. Actually, no, sorry, we didn't close it yet. On this one, we are going to close it. Sorry, we're not going to close it. I'm getting confused that this is part of it. It's actually this. So we keep opening, and then this next one we close, but the last one to it is not its opposite, so we end up with something else. So if I drag that down, it carries on, gets a bit confused with different things, but actually all we need is this first time there's an issue. So basically, in fact, let's just change, rather than else, let's just call that end, because that makes more natural sense. So we do that down, and what we need to now look for is we need to X match the word end in this range to tell us when we get an ending, and then what we're asked to do is find the bracket that goes with it. So what we're going to do is we're going to index into this on that number 6, which will give us the, oh, that's the open bracket. So let's put in front of that index into, it won't be f4 hash because that's not, no, yes, it is a dynamic range. So f4 hash based on h4. And if I were to join those together, we should get a open and close set of brackets. So I'm just going to then put in between those the actual number, and we get brackets 6, and we point to that, and we're all good. And we're at 70 minutes. So that took 7 minutes to do that level. So almost the whole time, half the time was on that. Okay, right, let's go to the bonuses. What is the total number of letters, uppercase and lowercase, considering all text strings from 1 to 7? So if we look at the questions, we've got text strings, but we've also got consonants and vowels, strings and numbers, and then the last question isn't text strings, or not letters anyway. So what I'm going to do is open a new sheet. I'm going to use case questions on 1 to 6, which is going to give us lots of data, but we're going to basically say we only want those where the length is longer than the word consonants, because anything less than that is not to be included. So what I'm going to do is I'm going to call that. I'm then going to say let A be that, and then I'm going to say filter A where the length of A is greater than the length of consonants, and make sure I spell it correctly, consonants, and that should return only proper text string. And if we get 110, which I know from memory is correct. So got all the strings. So the first question was, what is the total number of letters in all of those strings? So let's do ourselves a favor. Let's give this a name and call this AQ for all questions. And we're going to say, what is the length of the concatenation of AQ, which gives us 5755. How many times does the letter A, lowercase, appear in all of those? So we're going to say, count the occurrences of lowercase a within the concatenation of AQ, but we're going to select case sensitive, and we get 92. What is the absolute difference between the number of vowels and consonants across all those questions? So let's have a look at our list. So let's get our vowels, and let's call them, let's go A, E, I, O. Actually, no, let's do this using regex. So what we're going to do is insert an extra row, and we're going to say we want to we want to text characters, the concatenation of all questions. And now what we can do is do a regex test. So a regex test this on whether it contains A, E, I, O, U. Let's put that as the uppercase of B2, so we're not worrying about case sensitivity. And that gives us a false because K is not a vowel. Change it to 1s and 0s, and we do that down. We see we get ones where I presume that's capital I and so on. So let's sum that. And then let's just not copy that. Let's copy this, put it here, and put a hat symbol in front of there, and that will basically negate those. So say where it's consonants, probably could just add not the opposite one. So let's fill that to the right to get our sum, and then let's just take the absolute value of that minus that, although we know that's larger, so we get 3597. And then concatenate all answers from level 4. After this, reverse them backwards this text string and we get a word. So we're just going to say reverse the concat of level 4, which spells out the author's names, Klinsmann and Diarmid. And then what is the sum of the odd answers from question 6? So what we're going to do is sum the filter of the answers from question 6. That's that. Oh, done something wrong there. I don't think I didn't put an equals in front of here. So when I went to then select the range, it didn't select it for me. So question 6, we'll select all of that. We want to filter that where if we go by row in that same range, so E209 to E228, testing whether it's odd, we should get that together and we get 296. And how are we doing for time? 20 minutes, 21 minutes. Okay, so I said definitely under 30, maybe under 20. Maybe under 20 was just a bit of a stretch, but yeah, good case, good practice, lots of textual analysis. When I did this the first time, trying to do it in half an hour, I did what I've did today. So I did all the bonuses, did levels 1 to 6, struggled on level 7, got half of level 7 because my original approach was basically, I'll just show you now what I did was I basically took all of the sets, in fact I don't even need those first ones, just the first sets, and basically then found all of the ones, so I can show you here. I basically said here are all the closes, here are all the those are the openings, close. I said let's take all the combinations, which I use bucket combos, and then basically just kept the ones where if I now join these together and copy those as values, I basically found the ones that weren't matching pairs. So basically that was it, and then basically kind of said yeah, let's think about this, search for these within the text string, we get some, and so in this case the minimum of those. So if I then said 2col of that to get rid of the errors, and then said give me the minimum of that, and I realized in the example it's 6, so I kind of manually added 1. Oh, not added 11, so added 1, and then did the same thing here, where so if I actually just temporarily have that point to this, you'll see we'll get about not even half, maybe a third of them right by just finding the first time there's an actual mismatch, but that didn't deal with the fact that sometimes there was an opening and a closing kind of next to each other, if that makes sense. So yeah, that's how I got on first time. So I would have dropped however many points that was in the live attempt, but there you go. So yeah, good case. I hope you found it helpful. As always, great help for me to do this work. So thanks for watching.